In angle, as we have seen in linear measurement basically covers 75% of inspections in the manufacturing industry, and rest 10 to 15% inspections are covered with the angle measurement, because there are many components in the manufacturing industry who have different angles in their construction. In angle measurement, typically we can measure angle with bevel protractors, sine bar. We have not angle, but for measurement of levels we have spirit levels, we have angle takers, we have angle gauges, we have profile projectors. What we do have in our lab, that is MPC lab in our department, is we have bevel protractors. We have two bevel protractors. We have a sine bar. We can measure levels with spirit level. We have a very advanced instrument which is optical profile projector. We can measure angles with this, but however for this particular experiment, that is experiment number 2, which is angle measurement using bevel protector and sine bar, and we will see angle measurement using this profile projector during its use. So this is what we are going to do today. We will measure angle by using a bevel protector with some component, and in next session we will measure angle using a sine bar. So this is a bevel protector. Bevel protector basically is extension of protractor. So in case of protractor, we can measure angles up to 0 to 180 degree. In case of bevel protector, we can measure angle from 0 to 360 degree. Sometimes these bevel protectors are known as Vernier bevel protectors also, because they are using same principle as that of Vernier instruments. That is, these bevel protectors also have two scales. One is main scale, one is circular scale as that of Vernier caliper. But only difference is that these two scales are circular scales. In construction, bevel protector basically consists of a metal plate like this. This is the metal plate, and on one side of metal plate, one stock is there, which is used as one of the reference while measurement of angles, and on the blade one full circular scale is provided, which measures from 0 to 360 degree. Only for measurement purpose, this scale is divided into 4 quadrants, from 0 to 90, from 90 to 0, from 0 to 90, and from 90 to 0 again. That means over this particular scale, graduations are provided from 360 degree, but they are divided in span of 90 degree. 0, 90, 90, 0, 0, 90, 90, 0. This is just for ease of measurement. When we are measuring angles with help of bevel protector, this becomes simple to measure angle because of this particular quadrant. Above this plate, one rotating turret is provided. This is the rotating turret. On this rotating turret, a small Vernier scale is provided. Just see here, this is the Vernier scale, and on this instrument, this is the Vernier scale. So this Vernier scale is basically having 12 circular divisions, 12 from one side of 0 and 12 from other side of 0. So when you rotate when you rotate blade in this direction, I will show you what is mean by blade after this. You have to read from 0 in this direction. When you rotate blade in other direction, you have to read 0 in this direction. We will see how to read this while actually when we take the measurements. So this is basically known as a Vernier scale of this. Bevel protector, while using, it is provided with blades like this. So these are two blades provided with a bevel protector, and these are two blades provided with this bevel protector. These blades are used for measurement of angle with help of this blade and with help of this stock. Basically, when you are inserting a blade, you have to lose this locking lever, you can say, and you have to insert a blade from this side. Inside this projection, one more small projection is provided over here, and this has a reference of this rotating turret. So you have to insert this, and then you have to lock this lever in a position. Once you do this, you can measure angle with help of this bevel protector. That is by using this stock and this blade. For example, suppose I want to measure angle of a component. What I am supposed to do is, I am supposed to rest this stock at this face, and I will rotate this blade so that it will touch the component at angular face like this. So I will touch it like this, and I will lock this into position, and I will bring the blade and this stock into position of the component. So this becomes the angle. Or for example, I can measure angle in this fashion. I will show how to measure later on, but just see the positions of this bevel protector. I can measure angle in this position. or I can measure angle in this position also. Idea is very simple. You have to bring the angle of component between these two reference faces of the bevel protector, that is with the blade and with this stock. While using bevel protector, first of all you have to bring bevel protector in this position on the surface plate, so that stock and this blade will come in line. In this position you have to check whether 0 of this vernier scale is in line with 0 of main scale or not. The main scale and vernier scale have typical graduations provided over here. For example, if I consider main scale, the main scale graduation starts with 0 and they end up at 360. That means there are total 360 divisions on this main scale. Each division of main scale corresponds to 1 degree. That is 0, 1 degree, 2 degree. Likewise from 0 to 10, 10 degrees are there. 10 to 20, again 10 degrees. 20 to 30, again 10 degrees. Likewise total 360 divisions are there. That means the scale is graduated up to 0 to 360 degree. And the vernier scale is having graduation like 0, then 1, 2, 3. Each division here corresponds to 5 minutes. Okay, each division here corresponds to 5 minutes. That is 0, 5 minutes, 10 minutes, 15 minutes, 20, 25, 30, 35, 40, 45, 50, 55 and 60. So here total 12 divisions are there. Each division corresponds to 5 minutes. Similarly 0 in this direction 12 divisions are there. 0 in this direction 12 divisions are there. We will see why these two set of divisions are given when we actually use the instrument. To use bevel protector, I want to measure angle of this component. This component have this angle, it have this angle too, and it have a taper angle also. So all these angles can be measured with help of a bevel protector. To measure angle, as I mentioned, first you should keep bevel protector in this position, then move it, touch the stock to one of the face of the component like this, then rotate the blade so that it have a perfect contact to the component. So the component and blade will come in this position like this. Okay, in this position you have to lock the instrument. In this position you have to lock the instrument. Now when you are using this instrument, what will happen is, for example here in this case I have rotated blade in this direction. Okay, I have rotated blade in this direction. So what I am supposed to do now is, I should read main scale from 0 in this direction, that is in anti-clockwise direction, and I should check vernier scale from 0 to these 12 divisions, that is from this to this direction. When you rotate blade in this direction, that is in clockwise direction, you should read main scale in this direction and vernier scale from 0 to these 12 divisions. That is what the basic principle of this bevel protector is. So I have transferred this angle of this blade and stock inside the vernier bevel protector. So while reading this bevel protector, as I have rotated blade in anti-clockwise direction, we will read from 0 in this direction and we will read from 0 to these 12 divisions. Its principle is as that of my vernier, that is you should read main scale first. Main scale is that division which has been crossed by 0 of vernier scale, and vernier reading is that, means you have to find out a matching line between main scale and vernier scale. So it is as good as same as that of vernier caliper, only we are supposed to read circular scales. So according to this, the division which has been crossed by 0 is this one, that is 40, 45 and this one is 46. So division number 46 has been crossed by this 0. So main scale reading is 46 degrees. To read vernier, there are two ways in which vernier should be read, that is either in this direction or in this direction. Since I have rotated blade in this direction, I will read these 12 divisions. That means I will find out match from these 12 divisions. So division which matches is division number 4, that is 0, 1, 2, 3 and the division number 4 is in line with the main scale division. So 4 means 4 multiplied by 5 minutes. So 20 minutes is the vernier scale reading. So 46 degrees and 20 minutes is the reading. Just to understand this concept, I have shown the reading over here. A rough sketch of the reading is shown. We have rotated blade in this direction. So I will read from 0 in this direction 10, 20, 30, 40, 50. So each division corresponds to 1 degree. So 40 degree, this is 41, 42, 43, 44, 45, 46. So this division has been crossed by this 0. So my main scale reading is 46 degrees. Okay. To read vernier, either you should read in this direction or in this direction. Since we have taken reading in this direction, I will read from 0 to these 12 divisions. So division number 4 is in line with the main scale division. That's why vernier scale reading is 4. To read total reading, main scale plus vernier into least count. Main scale is 46 degrees, vernier scale is 4 into 5 minutes. So that's why reading is 46 degree 20 minutes. But while measuring angle, what we have done is we have adjusted blade from this to this position. Okay, and I am supposed to read this one. So what we have done, we have rotated blade from this to this direction like this. So that's why my final value of angle is not 46 degree 20 minutes. What has happened, we are supposed to measure this angle, but actually we have measured this. Okay, so to find out this, what I can do, x is 180 minus theta. So our theta is 46 degree 20 minutes. So 180 minus 46 degree 20 minutes. So angle actually is 133 degree 40 minutes.